Hey there. Let's listen to the global voices in drones and development. These are a series of masterclasses, interviews, and discussion on the use of drones and drone-based technologies for sustainable development and social impact. So let's get started.
Right. Okay. Okay. So very good evening to everybody, and thanks, Richie, for accommodating this presentation. This is going to be probably a little different, I presume. Based on this, I have not been able to attend every single presentation, but I'm going to talk about industrial inspection, and it's important for, I guess, to uh, introduce what industrial inspection is all about. So obviously acknowledgements to long list of people I worked at the Indira Gandhi Center for Atomic Research in Kalpakam, and then last 20 years at GE Research here in Bangalore, and of course to my alma mater, MS University and IIT Kharagpur. The industry spectrum is very vast, and you all have experienced, be it oil and gas, aerospace, renewables, automotive, offshore, manufacturing, locomotive, shipbuilding, whatever it may be. So everybody is into the game of manufacturing components and structures, and then or producing power or producing oil and things like that, or transporting you from place A to place B and so on. And what is also unfortunately sad is that the engineering components do fail. Not a pretty set of pictures which you would ever like to see in your lifetime, but does happen. Engineering components and structures do fail, like the ones you're seeing here: wind turbines, railway accidents, because of the crack in a railway track or in the axle. Even something as advanced as the space shuttle built by NASA have undergone failures. And then, of course, something very as mundane as something like the amusement rides. The one bottommost row, if you see the second picture from the left, is actually an amusement ride which failed because of improper inspections being done on the wire rope, which is one of the main elements of many of the amusement rides, and of course boilers, turbines, and so on and so forth. So the essential thing in all this is about quality. So you have to ensure quality of the component when it is manufactured at the factory, and then once it is put into service, you do need to inspect it. Again, the whole domain of inspection and NDT, as I will just call it in a minute, is all about ensuring quality right from the raw material to the built product to in service. That's the main aspect of this. And as you know, if there are failures, it's not a desirable phenomenon, and you do have loss of property and loss of human life, both of which are absolutely undesirable. So one has to assess the consequences of failure are well known, but what is the susceptibility failure and what can be the loss, and accordingly adopt technologies which can actually help alleviate them. So I'm given that there's a mixed audience and everybody may not be aware of what NDT or NDE is. I thought it's worthwhile sharing the definition. Non-destructive testing or non-destructive evaluation is basically inspection of interrogating or materials in a totally non-invasive, non-harmful way, but figuring out the state of the material. So the simple way to understand this is an equivalent of a doctor. When you go and when you fall down and unfortunately potentially have a fracture in your ankle or somewhere, you have no way of knowing whether it's a fracture or not. You go to the doctor takes, and even the doctor has no way of knowing. Okay, he will do some symptoms and may decide it's a sprain, but always advise an X-ray. And when you take the X-ray, the doctor sees the X-radiograph and determines you have a fracture, and so you need to go and get a plaster done. Or no, it's not a fracture, so it's probably a ligament tear or a sprain or something, and you could just do with a crepe bandage. So exactly. So the same tools which doctors use in the hospital, ultrasound, MRI, CT scan, X-ray, everything is what we in the industrial world also use to interrogate or inspect materials in a non-harmful way, and so that we figure out what is wrong with the material. So NDE is cradle to grave technology. as we call it, because it starts from raw material to materials processing to component manufacturing, and when it's put in service, be it an aircraft engine, a railway track, a railway locomotive, your cars, your bicycles, everything around you has undergone some kind of an NDT. So you may not realize it, but that is. And when it comes to critical components like nuclear defense and space, there is obviously much advanced technology which is used. Every nuclear reactor is inspected. Every aircraft gets inspected. Be this kind of technologies. So there's a bunch of things. There are defects or flaws in the material, and then it gets loaded because when an aircraft engine is an aircraft is flying, the aircraft engine, the turbine is rotating at a high speed, so it's undergoing some kind of loading. And in spite of our best designs and all, it undergoes deterioration. Pipelines in refineries undergo corrosion, okay, and things like that, boilers and many other stuff. So these are what are called assets. And every asset owner for an airline, their assets are their aircrafts, and of course the human assets are always there. So here I'm talking about physical assets. And if you talk about a refinery, they have a huge asset in terms of reactors, pipelines, all kinds of stuff. A power plant has a turbine, boiler, many things, and so on and so forth. So if you look at the asset characteristics, they are very widely varying. An aircraft engine is reasonably a small asset when you compare to a refinery, but it's very powerful and also very tightly packed. So it has its own challenges. So we talk about the heights of the asset, the large area of the asset, large lengths like in pipelines, and things like that, complex shapes like in the case of wind turbine blades and many other things. And of course, remote locations. Assets can be anywhere around the globe, in a desert area, offshore. If we talk about offshore wind turbines or offshore rigs, oil rigs, they are in a very remote location. And the challenges all of these people have is that they have to inspect them, but they have limited shutdown period. The areas to inspect are large, inaccessible areas, hazardous environments, confined space entry, and things like that. And the general indication is that most asset owners are able to inspect only 5 to 7% or less of their assets in the available shutdown time per year, which is typically a week or 10 days every year. And that's where Industry 4.0 really is going to play a big role of trying to integrate these fundamental technologies of X-ray or ultrasound or whatever we use for inspection with all the advanced technologies of Industry 4.0, and we call it NDE, non-destructive evaluation 4.0. That's what we call it. And there, all kinds of delivery devices like drones and robots and crawlers play a very big role, because we have to carry sensor payload and do the inspection of these assets. And here is just a sample shot of how a drone has taken pictures, aerial view of a potential refinery, for a wind turbine, an offshore rig, and inside a tunnel kind of structure. And from outside, Airbus is using it to inspect their aircraft, brand manufacture a new aircraft. So the assessment of these asset condition assessment is very important. So there are several models and things like that, but I won't go to the details. But yes, with the increasing use of drone video imagery is being used along with many other things to do a different type of asset management. So conventional asset management just uses conventional techniques and stuff like that. But here you can see that now it is being taken into an entirely different domain by using extensive use of drones. The advantages of drone inspection over standard methods, it's very natural for everybody to assume. Obviously, less downtime. You don't have to shut down the plants, right? Because you can just fly the drone. There's no human being which is going to climb up a chimney and do the inspection. And so, when you can keep your operations of the plant on, and that's what the biggest requirement for an asset owner. And of course, you can reduce the exposure of danger to all the operators who do the inspection going into hazardous environments. Of course, you can get accurate data, reduce inspection cost, improve asset reliability, and the biggest thing, save a lot of time. So the drone-based inspections, how do they work? So the inspector and operator design the route and monitor the UAV flight. UAV inspects the asset, whatever they may be. It could be a wind turbine, it could be an offshore rig, it could be a transmission line, it could be a power plant or a refinery. Okay, and they receive the data, and then you obviously analyze the data using various different models, and then really decide on what needs maintenance. Just again taken from open source reports. the estimated savings are huge. And as you can see here, achievable in terms of oil rigs, 90%, storage tanks, 70%, wind turbines, 50%. And of course, all the other things which come with it. Biggest thing being human being safety. And here is some value proposition by survey by different people who have done it. Clearly, you can see users of drones. So 53% are using it for inspection, which is quite huge. And the biggest use is in infrastructure. Okay, so which is again assets, and things like that. And there is huge cost savings, which can be well shown here through various things by by many people who have done it. So if you take the example of oil and gas assets, we are talking about upstream, midstream, and downstream. So upstream is where the source is, where it could be even subsea and things like that, or offshore oil rigs. And then, of course, the midstream is where it all gets, transition to the refinery, which is really the downstream. So in all the cases of upstream, midstream, and downstream, drone-based inspections of whatever it is, different types of inspection. It could be corrosion inspection, could be just the asset inspection of something going wrong, etc. Has huge applications. Here again, an example of storage tanks. Huge, very huge. The size of a football field. And very difficult to inspect by sending inspectors always inside, even after it's clean and stuff like that. Offshore, of course, is a totally different ball game where difficulties of inspection is well established. Pipelines run to thousands and thousands of kilometers for any refinery or an oil company, and there is no way anybody can go and really do inspection. So they always do selective inspection based on previous data, but drones allow them to do a little more elaborated inspection. Railway assets, huge opportunity again for inspecting these assets. You can use a lidar or a laser-based other mechanisms to actually map the track gauge. The track gauge over the years of usage gets shifted, and it's very important that they maintain the track gauge, because otherwise it could result in an accident, or going inside tunnels and doing the inspection of the state of the railway tracks and so on. So railway assets is a huge thing. Solar farm inspection, again, an industrial asset, which is generating renewable power. And, we all know the solar farm is huge. So again, drone-based inspections for module faults, string faults, and, balance of system and so on and so forth. Coming to one specific area of wind turbine, wind turbines, again, huge structures from several hundreds of feet tall, and each blade is several, 70 to 80 meters long. Very, very difficult if you had to do inspection once the wind turbine has been installed and made operational. And clearly there is data which shows that the biggest downtime is because of blades, 34%. And the biggest cost is again because of blades, 30%. So clearly there's a huge business case for inspecting wind turbines using drones. So here is how they traditionally were doing it. They had to bring the blade down using a crane, which would cost several thousands of dollars for rental per day. Then you bring the blade down and then do the inspections visually and other technologies like ultrasound and many other things. And you may find everything is all right, and then the whole effort was wasted. So how do we, kind of utilize drone to reduce? And this is how people do inspections of blades and towers. This is called rope access inspection. Now, these guys are actually having ultrasound probes, and they are actually monitoring the tower and the blade. Very, very dangerous and very time consuming. Okay, and the same thing in the offshore wind turbines also. And here is how, the whole drone-based usage, you can take it on a ship right close to the offshore and then, fly them, collect data, be it visual, infrared, ultrasound, whatever you want to, and actually make life much, much simpler by doing all this. Infrared imaging for wind turbines, excellent use of drones, because the payload is very light, and you could mount it on the drones along with visual cameras and really get a lot of additional information by infrared imaging, because these blades are made of a material called composites, and composite inspection, infrared imaging is an excellent tool. And you can see here how they have detected various kinds of damages, erosion, corrosion, and so on. So for wind turbines, the drone compatible sensors are RGB cameras, thermography or infrared imaging, ultrasound, and of course, multispectral cameras. For some of them, like xerography and radiography, it's not very convenient to have very heavy equipment and so on. So the benefits of drone inspection, no need to highlight. Huge savings, productivity loss can be reduced, downtime from failure, and of course, decreased in inspection repair costs. And what was taking many days, 2, 3, 4 days, today we are able to do that inspection in 40 minutes per turbine. That's a huge productivity saving, and complete automation today is possible. So combining AI, which is part of Industry 4.0 or NDE 4.0, combining AI with the drones and with NDT sensors to do a completely automated visual inspection. And here is the where completely total automation is there, right from the drone path planning to putting AI in terms of determining where you need extra images to be taken, etc., to analysis of the images and making the determination on the health of the wind turbine. Thermal power plant boilers, there's huge structures, several 3, 4 stories tall, with a huge number of tubes inside. Typically, they put up scaffolding, and then a guy will go inside and climb and do like what you're seeing here. Now, that entire thing today can be done with drones. So you send a drone with visual cameras, high definition cameras into this boiler, like you can see in the bottom photograph. It'll go inside, take the picture of the entire boiler, give you details of where the damaged areas are, and then you could send a human being only and put up a scaffolding there to do the further inspection using, say, ultrasound or any other technique, and then do a repair if needed. So huge application in the power industry. Aircraft quality inspection, Airbus is already been using it at the end of the production process before delivering it to the final customer, the airline. They are inspecting the entire aircraft using drones, which is, as you know, the structure is very large, and they have brought it down, from 2 hours to less than 15 minutes, which is a huge productivity saving. And of course, here we are looking at how drones can be combined with crawlers, robots, and other devices to get a very holistic picture, because there are things where you need to be in contact with the object you're inspecting. And when you're talking about drones, yes, they are moving towards that domain, but it's still, it may take a while before all the sensors we have in the NDT domain can be integrated with a drone. Today, non-contact sensors are very easy. As I said, infrared cameras, RGB normal cameras, ultrasound to a large extent has been already drone enabled to make sure that it goes and puts it in contact of the object being inspected. And so the COVID has been, in a way, an enabler for technology adoption at a very fast pace. And, we saw a huge adoption in the inspection world, at least that's where I come from, on remote inspections and drone-based inspections for many of the structures, including wind turbines and many other places, where traditionally they would have waited many more years to, saying, okay, we'll wait for others to do it and then we'll adopt it, and so on and so forth. So here's a nice statement, which again, many of you would have said: beyond asset inspection, drones will have a significant impact on all jobs that meet the 4D criteria: dull, distant, dirty, and dangerous, which is what all our engineering components are. Typically dull, because nothing great, exciting there. It's doing its job. Distant, again, in very remote areas, it is there. Yeah, they do become dirty when you talk about boilers and things like that. And of course, dangerous. Yeah, the wind turbines and boilers and many other things. Pretty dangerous for human beings to be hanging up there in the air and trying to do inspection with full concentration. Of course, again, I don't know, but I posted a question during our group and asking them for what is it that when did you do your first drone-based inspection? And of course, I know, Richie, you answered 2019. I did see many answers, and this is just for one as an aside. I did my first drone inspection way back in 2010. When drones were hardly around here in India. I was working for GE, and we did a trial run at the Kanyakumari wind farms, where wind turbines were there, and we did have a patent also in 2012 around that, about inspecting wind turbines. So just out of curiosity, I thought I should share, because I didn't know who in India really did the first inspection. So in summary, asset integrity and management is very critical from the angles of safety, reliability, and productivity. Assets in industrial plants vary in size, complexity. I showed you an example of many of those things: materials, location, etc., etc. NDE and inspection are an integral and core part of the strategy in any asset integrity program to prevent and avoid failures. Increased adoption of drones as a delivery mechanism for inspection can help significantly. Efficient, effective inspection by reducing time and cost, and inspection of large and inaccessible areas. And of course, biggest thing, increase personnel safety, operator safety, which should be our highest on our mind. Several NDE sensors have already been integrated for drone inspection, and we would hopefully see many more getting integrated in the near future. With that, thank you. Hopefully there was something useful in this presentation which you could all take back. And this is a growing area and a very potential area for more people to get in and do something very useful for industrial assets. Thank you very much, Ruchi, and happy to take any questions.
Thank you very much, Shyamsunder sir, for your presentation. It was really inspiring. Thank you so much. And thank you for also keeping the baton up for the industrial inspection drones, because you've been doing it for so long. Definitely, there is a lot for the youngsters who are trying to get into this industry, into inspection space, to learn from you and know how exactly it is supposed to be done and what not to be done as well, especially the safety aspects of it. So have you seen, like, over the last entire decade and a little more than that, the way the drones have evolved, has it improved the quality of inspections or the efficiency at which you work? Has it really added to your expertise?
Oh, absolutely, absolutely. I mean, again, it's been slow on its uptake. India, very few, I think, to the best of my knowledge. But abroad, yeah, people have already started using it pretty extensively. And so anyone who has used it just has only nothing but positive things to say about all it did in terms of the business benefit and so on and so forth. So clearly we are seeing an increased use, but as I said, we have to use different technologies, ultrasound. We may have to use several electromagnetic technologies and things like that. And some of them need the sensor to be in contact with the equipment we are inspecting. And that always puts a little bit of an issue, because maintaining constant contact with the drones is not still at the level at which we would like. So that could lead to errors. So non-contact sensors, absolutely no problem. So visual and infrared extensively being used. Ultrasound is started. There are several companies who already mastered that art and are doing it. And hopefully we'll see other sensors. So clearly the benefits, you can see the structure side, wind turbine, huge structure. And just the cost assessment will tell you that a drone inspection will be way cheaper than doing what they are doing, like sending a person up and risking his life. Or obviously he is not going to be doing the best of inspection, because he's hanging up in the air and putting some sensors on the blade and measuring. Obviously you can't be very comfortable doing that, however experienced you are. So why not change to drones? Simple.
There is a question that there are many variables in inspection needs, and in turn that there are many variables in platform type and sensors that are needed. So how do we start with so many variables to consider?
Yeah, I think it all starts with the asset which you want to inspect. That will really determine everything in terms of the what first the asset and what are you looking for. Like the wind turbine blade, as I told you. I mean, we are very clear. We know exactly what we are looking for. We want to inspect the blade 360 degrees, which is in the shape of an airplane. Okay, and it's close to 40-50 meters long. Okay, it's made of composites. We know what kind of defects happen in composites, either during manufacture or due to a bird hit or due to a lightning strike. Okay, you saw some pictures in my first slide, how the blade has completely broken. Okay, and it just happened. So there was no way for them to know. So we will assess the asset itself, damages, what we are looking for. Can it be picked up by our existing sensors, like high definition cameras or infrared imaging or whatever it is, and then decide on the platform, the sensors, and then the whole mechanic. So everything will start with what is the asset you want to inspect, and then knowing enough about the asset and what causes its failure.
There's another question. Is there any issue with intrinsic safety in high hazard flammable areas and or decontamination in, for example, toxic environments and or radiation risk inspection, such as nuclear plants?
Yeah, so radiation, I have not seen anybody doing a whole lot of it. Again, limited information at the moment, so can't comment on it. But should not be a big problem. Again, it will be related to the extent time of flying, because again, the electronics could get damaged in radiation environment. So you really have to watch out for that in terms of any extensive flying, especially in this thing. Other than that, the other areas, yes, I think we will have to explore. We haven't seen any big constraints coming, but yes, we will need, of course, all the permissions required, especially when you're talking about areas like refinery, where battery zones and other things are there, and inflammable things are there. You can't, you have to be doubly sure. I'm not very sure about any specific approvals or certification which would be needed to take that, but I have seen some people actually have already done it, and maybe that was in a non-battery zone kind of thing.
There's one more comment. It seems like inspection is not only visual, there would be many more ways of inspecting a structure. So there may be a point where somebody will have to climb up the structure as well. Is it right, or you have a different?
Yes, absolutely. So the idea is to reduce time and cost. So again, going back to my standard example of a wind turbine, what we have been doing till now, and we are continuing to do, is that we send a person up tower. We call it up tower inspection. The guy has to climb up that tall tower. No, there is no lift or anything. He has to climb. Then he goes outside onto the hub, and then he, sometimes the blade is kept in a horizontal position, and then he will, climb onto that, and then with, of course, harness and safety measures, but he will be doing all the inspection. And then at the end of it, you will realize that there is nothing wrong with that blade. Okay, now what we can do is to really just use drone to do a screening. Just go, because we can go very close to the blade, and with the kind of protective devices, you can actually do very thorough inspection. Even if with the most thorough inspection, we can do it in 2 to 3 hours. What would have taken him maybe a day or more than a day, apart from the risks involved. And once we see something which is unusual, which is imperfection, which is a defect, we could take a decision of bringing that blade down, right? Rather than just bringing it randomly, and then the whole 6 days or 7 days are lost, apart from the cost. So when the cost is involved is in the crane, about the operator, about the fact that for 7 days there was no power generation from that wind turbine, production loss, okay, and of course safety issues. So clearly, it's not about doing, but we are, in fact, I didn't have because it was 20 minutes, I didn't put in the videos. There's some excellent videos which actually shows the future of how drones will eventually be doing the repair of these wind turbine blades. It's futuristic, but obviously. So we could think of something where eventually a human being need not go onto the wind turbine, and we could do everything using a drone, or combination of drone and robot. So this video actually showed a drone carrying a small robot and leaving it on top of the blade, and then the robot will scan the entire blade and eventually do the repair. I mean, again, animated, futuristic vision, but it's possible.
Thank you so much, Mr. Shyamsunder. This has been an amazing presentation, and I think everybody out here has been inspired by what you just presented. And I hope to keep learning from you in the future as well. Thank you so much for making it to the conference this time.
Thank you. My pleasure.
Hey there. Thank you for listening to Global Voices in Drones in Development. We will be releasing at least one new episode every week, and that would be on a Saturday. So please do tune in. And you're most welcome to join the Global Alliance on Drones in Development, where we would be having podcasts, videos, masterclasses, meetings, discussions, and much more. So see you around. Thank you for listening.